So once again, we are forced to go with the video option here since we are not able to meet in person. And we're going to cover section 2.3 today. Even though it's not optimal, the weather is not cooperating with us, so we're going to go ahead and cover this way. What we want to do, we're going to talk about section 2.3, and we're going to talk about modeling with linear functions. So the first thing we want to make sure that we understand is that when we talk about modeling in math, we are talking about making up an equation to represent a situation, and then using that equation to help us figure out something about the situation that we're dealing with. So the first thing that I want to talk about is some guidelines to help us, some strategies to help us as we go through this process of modeling. The first thing we want to do is identify a variable. And a lot of times the variable is really determined by the question that is being asked, and so a lot of times we'll just use the variable as the answer to the question. So if somebody's asking for, let's say, the length of the side of a house, and we would use the variable to represent that length of the side of the house. So that would be an example there. We want to identify a variable. Once we've identified the variable, we want to express the unknowns in terms of the variable. Sometimes there are certain things we don't know, but we can use that variable to help us represent those values. Then we want to set up our model. And when we set up the model, again, that means we're setting up our equation that can be used to help us figure out something about the situation. Then we solve that equation and check the solution. Now the first thing we want to check when we think about a solution is we want to check to make sure that our answer is reasonable. Excuse me. So back to my example of the house, you don't want to have to get an answer for the length of a house and have it be a negative number. That wouldn't make any sense because you can't have a length that is a negative value. So check to make sure your answer is reasonable, and then also usually fairly quickly we can check algebraically to make sure our answer is actually correct based on our model. Then finally we want to give our answer in complete sentences, and whenever possible we want to go ahead and use the units. So again, back to our example of the length of the side of a house, typically we'd probably measure that in feet, so you'd want to make sure that you stated how many feet long the house was. So those are the strategies or the guidelines we're going to use as we go through these processes. So example 1, Emily saved up $3,500 for her summer visit to Seattle. She anticipates spending $400 each week on rent, food, and fun. Find and interpret the horizontal intercept and determine a reasonable domain and range for this function. So the first thing we want to think about here is what is the variable that we're going to use. And to me, looking at this, we've got some dollar amounts given to us here, but the one thing that we really are kind of unsure about is how many weeks is she staying? So let's use W to represent the number of weeks that she is staying. Now once we know that, based on the two other pieces of information they gave us, I'll just say there's a couple different ways we could go. One way we could go is to think about the cost and to say, well, yeah, the cost is going to be $400 times W, the number of weeks that she stays. But since they gave us that $3,500 at the beginning also, I don't think that's the direction this problem is going, so let's try something else. Since they gave us that value at the beginning, chances are they're more interested in how much money she has left. So let's let M equal the amount of money remaining. Okay, so the amount of money remaining is M. And if we think about that, she starts out with $3,500. And then we have to take away from that the amount of money she spends. So she spends $400 per week, and we already said in that previous equation that's going to be 400 times W. So the amount of money she has left is going to be $3,500, the amount that she had saved, minus $400 times W, and that's based on the amount of money she spends each week times the number of weeks she stays. Now the first part of the question says that we're supposed to find and interpret the horizontal intercept. Now the horizontal intercept, remember, is kind of the equivalent of the x-intercept. So in our case, we would call that the w-intercept. And if you remember the way we find intercepts, if we want the w-intercept, which is our input, we would have we'd have something, the w value, comma 0. And that means we're going to replace the m with a 0. So we're going to have 0 equals 3,500 minus 400w. Now, basically this allows us to solve our equation. So the first thing we're going to do is subtract 3,500 from the right-hand side to cancel that out, and we need to subtract the same thing from the left-hand side. That gives us negative 3,500 is equal to negative 400 w, and then we need to cancel out the negative 400, so they're multiplying, so we want to divide by negative 400, and that will cancel that out on the right. And so what we have left here is 8.75 equals w. So that is our w-intercept, 8.75, that's a decimal point, 8.75 comma 0. Now the question is, how do we interpret that? Well, we interpret that, if you think about it, that's when m equals 0, so that's when all of her money is gone. So how do we write this in a complete sentence? This means after 8.75 weeks, all of her money is gone. So she has no money left. So that's our interpretation of what that horizontal asymptote means. The next thing we want to do is we want to talk about the domain and range, and we've kind of already figured that out. Notice what makes sense. So let's talk about domain. Let me switch colors here. Let's go purple for a bit. Domain, and remember the domain is the input values, so for this problem we're calling that w. And the domain, if you think about what makes sense, does it make sense for her to stay a negative number of weeks on vacation? No. And so the smallest number that we could use is 0. And then when we think about weeks of vacation, assuming that you have to stay full weeks, either you would stay, let's just say she's not going to spend more money than what she has. So if she could stay 8.75 weeks, that means as far as full weeks, the highest amount of weeks she could stay would be 8. Now, if she gave herself a little cushion and she allowed herself to go in debt, then she could stay 9 weeks and still be just a little bit in debt, but we're going to say she's not going to do that. She's going to not spend any more than what she has. So that's our domain, from 0 weeks to 8 weeks. That's how long she could stay on vacation. The next thing they ask us to find is the range. So let's switch colors again. The range, and remember the range is the output value, so in this case that is an m. So the range, again, if we don't allow her to spend more money than what she has, the lowest amount of money she could have left would be 0. The highest amount of money that she's going to have is the amount that she saved, the $3,500. So the range there is going to be from 0 to $3,500. Remember, that's how we do our interval notation with the boundaries, and then we use the brackets to say, yeah, you could have actually 0 weeks of vacation. You could have 8 weeks of vacation without going negative. You could have $0 in the range. You could have up to $3,500 in the range as far as the money remaining. So those are our values, and that's the answer to that first example. For the try it now, which is usually one that I would have you try on your own, but since we're doing this with a video, I'm going to go ahead and work through it with you. It It says a database manager is loading a large table from backups. Getting impatient, she notices 1.2 million rows have been loaded. 10 minutes later, 2.5 million rows have been loaded. How much longer will she have to wait for all 80 million rows to be loaded? Obviously, that is a very large table. But let's take a look at what we know here. We are given some information. Let's think about the information first. 10 minutes and, she notices 1.2 million rows have been loaded. Then 10 minutes later, 2.5 million rows have been loaded. How much longer will she have to wait for all 80 million rows? So the question, here it is, how much longer? Let me underline that in red. How much longer will she have to wait? That's what we're trying to figure out. So let's just call that variable t. So t is the number of minutes that she's going to have to wait more than what she's already waited. Now this one is a little bit trickier because they didn't just give us an amount at the start and they didn't give us some other stuff. But what we do know is we kind of have two ordered pairs here, and we learned in our last couple of lessons how to take two ordered pairs and turn them into an equation. So the ordered pairs that we have here are right now, so in other words when time is 0, there are 1.2, and I'm just going to use 1.2, we're going to remember that that's millions, million rows loaded. Then 10 minutes later, she's at, 2.5 million, so 2.5. Now, if you remember what we could do with these two ordered pairs, we could find the slope. So slope, if you remember our formula, slope equals y2 minus y1 over x2 minus x1. So let's go ahead and plug these numbers in. And when we do that, we're going to have y2, which is 2.5, minus y1, which is 1.2. My dots are not showing up very well. And then on the bottom, we're going to have 10 minus 0. So that ends up being 1.3 on the top, divided by 10, which is 0.13. Now that's the slope. Based on that, we can write down our equation because notice right here, let me circle this and put a box around it in orange, we actually have the y-intercept, which is really nice for us because that way we know, remember our normal equation, y equals mx plus b. The m is the slope, which we just figured out, and the b is the y-intercept, which we know from that orange box. So that means we can write down y, the number of rows loaded, is equal to 0.13 times x, the number of minutes. I guess we're using, what did I say we should use, t? Let's go back and change that to a t. Times t plus 1.2. Okay, now the question becomes, how long will she have to wait? So that's our model. How long will she have to wait to get this 80 million rows done? Now that means the output, the y, is going to be 80. And we have 0.13 t plus 1.2. I maybe should have moved that to a different spot, but we'll just move it around as we need to. So again, we're trying to get the t by itself, subtract 1.2 from both sides so that we can cancel out that 1.2 on the left or on the right. When we do that, let me move this up here. We will now have 78.8 equals 0.13 t. Then we need to divide both sides by 0.13 to cancel that out on the right. And let me go ahead and do that division again using a calculator so I don't make a silly mistake. So 78.8 divided by 0.13. And it looks like we're going to get that t is approximately, let's just go with the exact answer that we get here first. So without rounding, at least according to my calculator, I get 606.1538. So that means from that time that she started, she's going to have to wait approximately 606 minutes more. Okay, now she's already waited 10 of those minutes, but she's going to have about 606 total minutes of waiting there for her to be able to get that. So I think I've got the answer here. So once we've got that work, we can write our answer like this. And we can say that she's going to have to wait another 606 minutes. That would be about 10 hours. So hopefully she doesn't stand there waiting that whole time. But that's how long she'll have to wait. Example 2, we have Jamal, and he is choosing between two moving companies. The first, U-Haul, charges an upfront fee of $20 and then 59 cents per mile. The second company, Budget, charges an upfront fee of $16, but then they charge 63 cents per mile. When will U-Haul be the better choice for Jamal? So, again, it's not specifically told in this case, but looking at what they've given us, a really good idea of what variable to choose would be this number of miles that Jamal is going to be driving, because that's really what determines the charges. Now, a couple things you want to think about. We've got two different companies here, and we're talking about the cost for each one. So let's just write a separate little equation initially for each one, and let's say the cost here, and I'm going to put this in blue. This is going to be U-Haul. Let me underline U-Haul so that we know that one's going to be blue. If you think about the cost, and you guys have probably had situations like this before where you have to pay for something and then you pay for how much you use it, well, he's going to pay $20 no matter what. And then, additionally, he's going to pay 59 cents per mile. So let's let, oh, I didn't come up with a variable. Let's let m equal miles. So we'll let that equal m. And then we're going to have 59 cents per mile. Now you have to be careful because this was $20. This is 59 cents. So we're going to write down 0.59 and then times m. So that's for U-Haul. The second company, which was Budget, let's do that one in purple. So the Budget company, their cost is going to be $16 as a flat rate, and then they're adding 63 cents per mile. So pretty clearly, if you're just renting it and driving a little bit, the Budget deal is better. Now the question asks, when will U-Haul be the better choice for Jamal? So we want to figure out when U-Haul is the better choice. So what we can do here is actually figure out when these two quantities, when these two costs are the same, and then based on that we'll be able to figure out when U-Haul is a better deal. So that's what we're going to do. We're actually just going to set these two things equal to each other. 20 plus 0.59m equals 16 plus 0.63m. So we want to find out first when are they equal, and that way we can figure out when U-Haul will be a better deal, because we already know that Budget is a better deal at the beginning. So let's see, let's get these m's together first. So let's subtract 0.59 from both sides, 0.59m from both sides of the equation. And that will cancel this out. So we'll have 20 equals 16 plus 0.04m. Now, you could have subtracted the 0.63m from both sides also and moved the variables over to the left-hand side. I usually like to subtract the smaller one so that I end up with a positive value if possible. But it's not a right or wrong thing. You can do it either way. Next, our goal is to get that m by itself, so we're going to subtract 16 and cancel that out on the right. So now we have 4 equals 0.04m, and then our last step is going to be to get the m by itself, divide by 0.04 to cancel that out. And when we do that, we end up getting that m equals 100. Okay, now what does that mean? Well, it means that the cost is equal for both companies if the number of miles driven is 100 miles. So we already had figured out that the purple one here, budget, is cheaper when you don't drive very far. At 100 miles, they're the same, and what that means for us is if I drive more than 100 miles with my moving company, then U-Haul will be the better deal. So our answer would be if Jamal drives more, I lost my S, pretend that has an S, I can't fit it on the screen, drives more than 100 miles, U-Haul is a better deal. Okay, and again, here's a little bit nicer. We'll have it typed up. So we can just say U-Haul will be cheaper if the trip is more than 100 miles. Example 3, and this one has a couple of different parts. It says a town's population has been growing linearly, so that tells us it's a linear function. In 2004, the population was 6,200. By 2009, the population had grown to 8,100. If this trend continues, predict the population in the year 2013. So once again, we want to come up with a model, and I think the model is going to be best represented by if we let, let's call it t, if we let t be the number of years, since they started with 204, let's say the number of years after, I said 204, sorry, 2004. Okay, now based on that, we get a couple of ordered pairs. The first ordered pair would be 0, because in the year 2004, the population was 6,200. The next ordered pair, 2009 is 5 years after 2004, so we would say 5, comma, what do we need here? 8,100. And we do this kind of similarly. We're going to, we did an example like this, I think it was example 2, but we're going to find the slope first. So our slope is going to be y2, 8,100, minus y1, 6,200, divided by 5 minus 0. So that gives us, in the numerator, 1,900 divided by 5. So again, I'm going to use a calculator here just to double check my work. I think it's 380. Yes, it is 380. Now remember, that's our slope. So in our case, I'm going to use P for population. Population will equal the slope times T plus the y-intercept, or in this case, it'd be the p-intercept. And remember that p-intercept, again, is given when the input value is 0, so we're going to use this. So let's see what we've got here. P equals 380 times T plus that 6,200. So that is our model. But again, we haven't answered the question yet. The question was to predict the population in the year 2013. Now the first thing we have to figure out is, since we let T be the number of years after 2014, how many years later is 2013? Well, if you are not sure about that right away, you can just subtract 2013 minus 2004. It ends up being 9 years. So what we're going to do is our input value, our T, is going to be 9 years. So let's just plug that in. P will equal 380 times T, which we figured out was 9, plus 6,200. And once you have that written down, that's really just calculator work. You can actually, on most calculators, just type that in all at one time. So 380 times 9 plus 6,200, and we get 9,620. So the population, according to our model, will be 9,620 in the year 2013. So there you can see that answer. Population will be around 9,620 in the year 2013. The second part of this question, when will the population reach 15,000? Well, we have to go back to our model again, and our model said P equals 380 times T plus 6,200. Now they're asking us, when does the population reach 15,000? So that means they're having us put in a p-value of 15,000. So let's go ahead and do that. 15,000 equals 380t plus 6,200. Then, again, our goal is to get that t by itself. So when will it reach that time, that population? So we're going to subtract 6,200 from both sides. That cancels out on the right, and it will give us, let me double check my work. I don't want to make a silly mistake. And we're going to get 8,800 on the left. Okay, then to finish getting the t by itself, we're going to divide by t. No, we're not going to divide by t, sorry. We're going to divide by the 380, which is by the t. And I'm not sure if this is going to come out evenly, but let's go ahead and do that, again, using our calculator. And we get approximately, well, let's write down the answer and then we'll approximate it. So t is going to be about 23.15789. Now remember that t is the number of years since the year 2004. So we can say sometime during that 23rd year, before you hit the 24th year, the population should reach 15,000 if this model holds. So 2004 plus 23 more years tells us that it should be in the year 2027. Sometime during the year 2027 is when, according to this model, the population will reach 15,000. And you can see that, again, written in a complete sentence there. The population will reach 15,000 around the year 2027. That's the end of what we're covering today, so hopefully you saw enough examples. It's impossible for me to cover every possible example of a word problem, so just understand that you are going to run into some things and you'll have to actually think through them to come up with your equation. But your assignment, I did shorten it up because I know that word problems are scary to people because they have to read through the words and then try and understand the problem and then make up their own equation to represent it. So you've just got 5 problems there to work on your Section 2-3 homework assignment. I'm also going to open up that Section 2-1 and 2-2 again in case some people haven't completed it. So if you haven't completed it or if you wanted some more time, you can work on that. If you did already complete it but you want some more time to try again, please email me and I will open that up for you so that you can get going on that or try it again. Have a good week, and hopefully I will see you next week.